One venomous predator stalks the American tropics. Out of 3,000 species of centipedes, it's the leviathan.
When you think of animals that threaten snakes, large birds, mammals, or other reptiles probably come to mind. But one of their most unexpected predators is only a few inches long. Giant centipedes can overpower snakes by wrapping around, restricting movement, and injecting venom through modified legs near the head. These attacks have been observed in forests, caves, and isolated islands, where centipedes hunt creatures many times their size. Their success proves that strength and size do not always decide survival. Sometimes speed, venom, and the right strategy are enough to turn a dangerous hunter into helpless prey. Unexpected snake predators emerge. Snakes are often seen as stealthy, efficient hunters with few natural enemies. Their diet is famously broad. They consume everything from rodents and birds to frogs, and even other snakes. However, recent observations have unveiled a surprising shift in the predator-prey balance. In several parts of the world, researchers have documented an unusual phenomenon: a small, overlooked predator actively hunting and slaying snakes. This creature is not a mammal or bird, but a giant centipede, an unexpected and formidable adversary. These centipedes, often hiding beneath rocks or leaf litter, were once assumed to feed primarily on insects and other invertebrates. Yet cases have emerged in Thailand and other tropical regions showing these centipedes capturing snakes, wrapping their long segmented bodies around their prey, and subduing them with venom. At first, these events seemed isolated, perhaps anomalies in the wild. But over time, similar incidents were recorded in island ecosystems, dense forests, and even in situations where the snake initially tried to turn the tables on its attacker. One of the most striking aspects of this new predator-prey relationship is that it challenges traditional assumptions about food chains. Snakes, typically higher-level predators, are now falling victim to animals many thought of as their own prey. These giant centipedes appear to have bypassed intermediate stages of the food web and directly targeted animals that were once considered a threat to them. This reversal adds a fascinating layer to our understanding of ecosystem dynamics. The first documented cases involved relatively small snakes and medium-sized centipedes, but the trend was clear. These invertebrates had evolved effective strategies for hunting vertebrates. This discovery forced scientists to reconsider the ecological roles of centipedes, expanding their reputation from mere insect predators to dominant hunters in their habitats. The newfound ability of centipedes to subdue dangerous prey like snakes indicates a complex and previously underestimated interaction between species. Even though this phenomenon is still rare and relatively understudied, it hints at a wider tendency, sort of adaptability and persistence among invertebrates. Snakes might end up physically larger, and they can carry venom or have constricting capacity, but those things by themselves do not really promise protection. The issue for snakes is that the centipedes use a different mode of attack, one that flips the snake's own strong points back on it in a way that feels kind of unexpected. Any tiny slip during a snake's defense can turn into a deadly meeting. The centipede's hold, running along the snake's length, limits movement, and it also messes with the timing of the usual defensive strikes. On top of that, venom delivered through specialized limbs can knock the snake out fast, effectively leaving it immobilized. This whole style of hunting makes the weak spots clearer in animals that were once considered close to the top of their local food web. Intriguingly, some snakes have even been found dead after swallowing these centipedes whole. And unlike a lot of predators that get subdued before they can fight back, the centipede's resilience and venom let it keep going, still fighting once it's inside its attacker. So there's this real paradox, where the prey ends up slaying the predator from within, and it just adds more layers to how complicated these interactions are. It also seems to point to this sort of odd biological warfare that might be happening. Scientists are only just starting to sort out how far this relationship actually goes, because plenty of mysteries still sit there unresolved, like how widespread is this behavior and which species are most at risk. Plus, what ecological consequences could show up from these predator-prey reversals that feel almost backwards. Those questions have already set up a push for more in-depth research, and everyone expects new revelations that could shift how we think about food chains in tropical ecosystems. The initial discoveries have sparked intrigue well beyond herpetology and entomology, pulling in attention from several other scientific fields as well. But before unraveling the key biological adaptations behind these lethal encounters, it's important to understand how centipedes operate as hunters, which is where this story takes an even more fascinating turn. The unique hunting tactics of centipedes. Centipedes are ancient arthropods with a deceptive reputation. For many, they are simply creepy crawlies that feed on insects in the soil. However, the hunting methods of giant centipedes reveal an incredible skill set that elevates them far above casual scavengers. Unlike most predators that rely on teeth or claws to overpower prey, centipedes use their many legs and venomous appendages in a uniquely coordinated way. At the front of a centipede's body lie specialized limbs called forcipules, which look like curved hooks but are actually modified legs. These forcipules serve as venom-delivering weapons, injecting a potent mixture directly into prey. This evolutionary adaptation is remarkable. No other known animal has transformed walking legs into venomous injection tools. The centipede's forcipules are short, powerful, and designed explicitly for gripping and holding prey securely. Instead of a quick bite or constriction, the centipede slays by wrapping its body tightly around its victim, using multiple legs to grip firmly at several points simultaneously. This multi-point hold restricts any attempt by the prey to strike back or escape. Meanwhile, the centipede moves fluidly with its prey's thrashing, keeping constant pressure and administering venom through repeated stabs with the forcipules. This relentless strategy requires stamina and precision and proves devastating in battle. This method contrasts sharply with predators like snakes or birds, which usually focus attacks on a prey's head or vulnerable spots. Centipedes exploit the fact that a snake's defensive power is concentrated in its head, its fangs, jaws, and sensory organs. By clinging around the body, a centipede effectively neutralizes these weapons, turning the long snake's flexibility into a disadvantage. The snake cannot protect itself because it cannot easily target the attached centipede. Studies show that centipedes don't have to slay instantly. The venom plus that steady grip kind of works on the prey over time. In a few documented cases, the struggle goes on for many minutes, and the centipede sort of keeps pressing, exhausting the snake while injecting more venom bit by bit. The result is almost always fatal for the snake, and it rarely manages to get away once the centipede locks in firmly. And this kind of hunting isn't just about snakes. Giant centipedes have adapted to attack a broad set of animals, using their flexibility, not only their versatility, to keep thriving across very different habitats. From the forest floor to island burrows, their power to immobilize and poison other creatures looks like a real evolutionary win. Something that pushes against the usual assumptions about what predators of this kind can actually do. The coordination behind this style of capture hints that centipedes rely on more advanced neural regulation across their many legs. Being able to keep a safe hold while injecting venom again and again suggests a complicated relationship between raw strength and venom effectiveness. It's that blend that lets them bring down prey that feels bigger, or frankly more threatening, than what you would normally expect from insect-sized hunters. All of these tactics really make you wonder about what else they target and what ecological role they play, which is way beyond what most people picture. Their unexpected success as snake predators is only one part of a bigger story about how they influence local ecosystems and how they fit into the food chains and networks around them. And their reach doesn't stop with snakes. These formidable creatures have preyed on an even broader array of animals, demonstrating that size and frightfulness are not necessarily a guarantee of survival against such relentless hunters. Deadly encounters beyond snakes. While the centipede's capability to slay snakes upends expectations, their dietary habits extend further still. In Venezuela, researchers discovered that giant centipedes are hunting bats inside caves, an impressive feat considering the size and agility of these flying mammals. These centipedes, some exceeding 12 inches in length, climb cave walls and cling to ceilings. waiting to ambush bats mid-flight or when they settle to rest. Their hunting position is unusual and effective. The centipede anchors its rear legs to the ceiling, freeing the front half of its body to snatch bats as they come near. Using the many legs to hold tightly, it grasps its prey and begins to feed, often targeting the neck and chest area first. Markings on captured bats reveal desperate attempts to escape, but the centipede's hold proves too strong. This behavior is not isolated. Multiple species of bats have been found preyed upon in the same caves, showing that giant centipedes have adapted this ambush predation as a specialized hunting strategy. It highlights just how versatile and opportunistic these invertebrates are when it comes to finding food sources in challenging environments. Moving from caves to islands, another striking example comes from Phillip Island, located off Norfolk Island. Here, a species of giant centipede known as Cormocephalus koinei grows to more than 8 inches and emerges at night to hunt seabird chicks. The island is home to thousands of black-winged petrel chicks living in burrows, providing a plentiful target. The centipedes enter these burrows, seize chicks with their venomous forcipules, and begin feeding while the birds are still alive, often starting at the neck. Researchers have documented hundreds, possibly thousands of chicks dying from these attacks annually. This predation pressure is significant, especially given that this island lacks native predatory mammals, leaving the centipede to fill that ecological role. Moreover, the diet of these centipedes is not restricted to birds alone. They also consume various small vertebrates like geckos and skinks. Vertebrates make up nearly half of their overall diet on Phillip Island, reflecting a highly carnivorous lifestyle uncommon among centipedes elsewhere. This adaptation to vertebrate prey displays both the power and predatory flexibility of these creatures. These instances of predation extend our understanding of the giant centipede not just as a menace to snakes, but as a top-level predator in their ecosystem. Their impact reverberates through these isolated environments, shaping populations of diverse animals and challenging preconceived notions about food chain hierarchies. With these observations, it becomes clear that giant centipedes have carved out a niche as deadly hunters capable of preying on some of the most elusive and agile vertebrates. Their ability to slay beyond insects underscores an evolutionary success that science is only beginning to appreciate. The story of their hunting extends across habitats and species, setting the stage for us to delve deeper into the biological and evolutionary secrets behind their lethal efficiency. The tenacity of centipedes and the surprising range of their victims reveal a world where size, speed, and even venomous defenses don't always guarantee survival. Next, we'll uncover the mysterious battles that rage even inside their prey, where survival takes on an entirely new meaning. Inside the struggle, when prey fights back. Sometimes a predator captures its prey, but still loses the battle. Researchers have documented disturbing cases where snakes swallowed centipedes whole, only for the centipedes to continue fighting from inside their bodies. One of the most shocking examples was discovered on Golemgrad Island in North Macedonia. Scientists found a dead juvenile nose-horned viper with the head of a centipede protruding through a tear in its abdomen. The snake had apparently swallowed the centipede alive, expecting the meal to be over. Instead, the prey may have begun attacking from inside. During the examination, researchers found that much of the snake's internal tissue had been severely damaged. The centipede's sharp legs and powerful body movements may have torn through the stomach and surrounding organs as it struggled to escape. Its venomous forcipules, the modified front legs used to inject toxins, may also have contributed to the snake's death. The discovery revealed just how resilient centipedes can be. Even after being swallowed, the animal did not become helpless. It continued twisting, gripping, and fighting, turning the snake's digestive system into a deadly battlefield. What should have been the final stage of the hunt, instead, became a fatal mistake for the predator. Similar incidents keep popping up in other corners of nature too. Along the Delaware coast, a heron was caught on camera, flying, while an eel hung right through its body. The bird had swallowed the eel, but somehow the prey apparently pierced its way out from the inside. What happened to the heron in the end was not fully clear, yet the photos made one thing obvious. Ingestion does not always mean a win. For snakes, Swallowing a risky centipede can create this odd kind of weakness. Their usual plan relies on swallowing prey whole, but that also gives a live centipede a chance to reach soft internal tissue. If it stays lively long enough, its legs, venom, and steady movement can produce nasty injuries that really add up. The result may come down to timing as well. Centipedes have been seen going after snakes during vulnerable windows, like when they are egg-laying. Since then, their motion and defensive reactions can be dialed down a bit. Even a handful of seconds of hesitation can end up deciding who lives. Overall, these moments blur the line between hunter and hunted. A snake might start off as the primary predator, then suddenly become the victim a short time later. The centipede can attack from the outside or keep resisting from within, and that gives it a pretty remarkable persistence edge. Nature offers no automatic triumph. Measurements, venom strength, and even reputation can mean very little if the prey refuses to give up. Sometimes, the tiniest creature changes a successful capture into the predator's last, final meal. From these fierce internal conflicts, we begin to appreciate the evolutionary arms race that has shaped centipedes into such efficient slayers. This transformation revolves largely around their unique venomous appendages, structures that redefine how they hunt and slay. Evolutionary adaptations of venomous appendages. Behind the centipede's deadly grip lies an extraordinary evolutionary innovation. The curved hooks that resemble enormous fangs are not fangs at all, but forcipules, modified legs uniquely adapted to deliver venom. Evolving from ordinary walking limbs, these structures have become specialized weapons capable of injecting a complex, potent venom directly into prey. This adaptation is unparalleled in the animal kingdom, marking one of the few times that walking legs have transformed into venom delivery organs. The transition involved significant morphological changes. Forcipules shortened and thickened, becoming powerful gripping tools with venom channels inside. They shifted forward from their original position, losing any role in locomotion to focus entirely on grasping prey and injecting venom efficiently. This specialization allows the centipede to hold its victim firmly while repeatedly delivering toxins with precision. The venom itself is a complicated cocktail of molecules targeting muscles and nervous tissue to incapacitate prey swiftly. Some compounds act on pain receptors, while others interfere with nerve signals, making the venom both paralyzing and painful. This biochemical arsenal not only subdues prey but also deters potential predators, giving centipedes a potent defense mechanism alongside their hunting advantage. Different centipede species exhibit variations in forcipule shape and mobility. More ancient lineages retain forcipules that look somewhat like legs, with a wider range of motion, while others have evolved short, powerful hooks optimized for holding and stabbing. These variations reflect evolutionary paths shaped by hunting strategies and prey specialization, demonstrating the adaptability of this unique feature. Functionally, centipedes don't bite as snakes do. Instead of delivering a quick strike with jaws, they grasp their prey with forcipules and pump venom into it through these venomous limbs. This means their bite is more like a venomous clamp, providing both mechanical restraint and chemical attack simultaneously. Such a method is particularly effective against active, struggling prey. This limb-to-venom weapon shift doesn't really match any other animal adaptation we know of. It took neural control spanning several coordinated legs, plus the emergence of venom glands and their delivery channels all bound together for hunting success. The end result is basically a weapon that feels like perfectly timed with the centipede's predatory rhythm. The centipede's power to knock down more than insects, and even vertebrates, largely comes from this evolutionary jump. When it targets snakes or other kinds of unexpectedly large prey, the forcipules let the centipede hold position and keep injecting venom while the victim thrashes and twists. That ongoing transfer neutralizes the prey's own defense responses pretty effectively. Research on centipede venom has grabbed pharmacologists worldwide, mainly because the mixture is intricate and might offer medical uses. Still, if you zoom out ecologically, the real explanation is the synergy between those venomous appendages and the centipede's own muscular body. That combo helps these tiny predators take down prey well beyond what their size would suggest. This evolutionary breakthrough places the centipede beyond being just a small prey hunter. Instead, it becomes a major predator, able to affect ecosystems through unexpected predation on snakes and other vertebrates. Those venom-laden limbs are the hinge that unlocks the mystery behind their lethal success. The unique weapons that give centipedes such an advantage over snakes are only part of the story. To fully grasp why snakes so often fall prey to these attackers, we need to consider what makes snakes particularly vulnerable to this brutal method of predation. Why snakes are vulnerable to this attack. Despite their reputation as skilled hunters and dangerous predators, snakes face a unique set of challenges when confronted by giant centipedes. One of the key reasons snakes struggle is rooted in their very anatomy. Almost all of a snake's offensive and defensive tools, the eyes, fangs, jaws, are concentrated at the front of its body. This specialization is highly effective for striking prey and defending against threats that approach head-on, but it turns into a liability when attacked along the body. When a centipede wraps itself tightly around a snake's midsection or tail, the snake's head and fangs can no longer deliver effective strikes. The attacker secures multiple grips along the snake's length, using numerous legs, turning the snake's long, flexible body into a cage rather than an advantage. No matter how much the snake twists, thrashes, or bites, the centipede moves in synchrony, maintaining pressure and administering venom steadily from several points. Another factor increasing vulnerability is the centipede's ability to stay latched on under intense struggle. Unlike predators that rely on brute force to overpower prey quickly, centipedes combine grip and venom to wear down their targets over time. This endurance hunting style is particularly problematic for snakes because any sustained physical attack can exhaust their energy quickly, especially if they cannot effectively bite at the source of threat. The timing of attacks also plays a critical role. Snakes are especially vulnerable during periods when their senses are compromised, such as while shedding their skin. During shedding, a fluid builds up between the old and new layers, clouding the snake's vision and dulling its sensory perception. This makes it significantly harder for the snake to detect approaching threats or to position its head effectively to defend itself. Snakes rely heavily on visual and proprioceptive cues to coordinate their attacks, so blurred vision or reduced sensation interferes with their precise strikes. A centipede's stealthy approach in such moments turns the odds heavily in its favor. Rather than chasing an alert snake across open ground, the centipede only needs to find its prey in a confined or sheltered space, where a snake's slowed reflexes and impaired sight leave it nearly defenseless. Confusion and pain during a centipede attack can trigger erratic behavior in snakes that worsens their plight. There are documented cases where snakes bite repeatedly in panic or pain and accidentally harm themselves, sometimes biting their own bodies or tails. These self-inflicted wounds do not slay instantly, but can cause infection and weaken the snake further, tipping the balance in the centipede's favor. In addition, snakes cannot always remove a centipede once it has locked on. The many legs gripping firmly make it nearly impossible to dislodge the predator without exposing the snake's head for a counterattack. This persistent hold, combined with targeted venom injections, ensures that individual snakes rarely escape these encounters unharmed. Size differences also matter. While large snakes like king cobras are mostly safe because they are too big to be wrapped fully, medium and small snakes fall victim more frequently. The centipede's method exploits the size and shape of these smaller snakes, using their own flexible length to immobilize them. This creates a predator-prey size threshold, where centipedes have little chance against the largest snakes but remain formidable against many others. Ultimately, snakes' specialization as predators ironically puts them at a disadvantage against this unique threat. Their body design, dependence on precise strikes, sensory vulnerabilities, and the centipede's multi-legged assault converge into a deadly trap, showcasing a predator-prey tipping point few had anticipated. The multifaceted vulnerabilities of snakes invite a wider examination of other invertebrate predators that have evolved surprising methods to hunt them, expanding the list of threats beyond centipedes. Other invertebrate threats to snakes. Centipedes are not the only invertebrates capable of hunting snakes. Around the world, Spiders and scorpions have also been observed overpowering small, young, and sometimes venomous snakes using strength, venom, and highly specialized hunting strategies. Large scorpions provide one of the most brutal examples. In Thailand's Sakharat Biosphere Reserve, the Asian forest scorpion, Heterometrus laoticus, has been documented attacking live snakes. The scorpion grips its prey with powerful pincers, tears into the flesh, and may continue feeding for hours. In some cases, it drags the weakened or immobilized snake toward its burrow. These encounters show that scorpions can become formidable predators, even against vertebrates that appear more dangerous. Spiders use a very different approach. Researchers have recorded hundreds of cases of spiders attacking snakes across several continents. Surprisingly, the most successful hunters are not always massive tarantulas. Smaller widow spiders and their relatives frequently rely on strong, tangled webs to trap snakes many times their size. A snake might end up crawling into a web by mistake, especially while it's moving through rough vegetation or just searching for prey. It keeps going at first, then, as it struggles, the silk kind of stacks up around its body, limiting its movement and also making it harder for the snake to strike with any accuracy. After that, it's basically stuck, and the spider, over and over, goes in with repeated bites, pushing venom into the snake, which then builds up slowly until paralysis starts to take over. In these kinds of fights, size is not always the deciding factor, not even close. People have reported tiny spiders subduing snakes that weigh several hundred times more than the spider itself. And even for species that are venomous, like rattlesnakes and coral snakes, there is no automatic shield. Their venom might be lethal, yes, but it becomes pretty much pointless if the snake cannot even reach the attacker. Unlike centipedes or scorpions, which often push with direct physical force, spiders tend to rely on patience. They wait, immobilize the snake, inject venom, and then they feed by slowly consuming the liquefied tissues over a period of days. Kind of slow, but effective. All of this shows that snakes deal with threats from some of nature's most unexpected hunters. Strength, body size, and even deadly venom don't always ensure survival. Sometimes, a spider only needs gripping pincers, a venomous sting, multiple legs, or a web set in just the right place to take down a reptile people fear. Taken together, these predator tactics point to how evolution works in a complicated way, where every creature figures out new ways to hunt, to escape, and yes, to survive. Facing such a diverse array of invertebrate enemies, snakes' survival depends on more than just their physical or venomous strength. The wider consequences of these interactions ripple through ecosystems and research, revealing how much remains to be discovered about these small yet profound battles in nature. Implications for ecosystems and future research. The discovery that giant centipedes regularly prey on snakes is forcing scientists to rethink how food webs actually work. Long dismissed as minor predators, these venomous arthropods have proven capable of hunting reptiles, birds, bats, and other vertebrates, showing that size alone does not determine who dominates in nature. In some environments, they play a much larger ecological role than anyone expected. On Australia's Phillip Island, giant centipedes slay thousands of seabird chicks each year, making them one of the island's top land predators. In caves, they also hunt bats, creating ripple effects that can influence insect populations and reshape entire ecosystems. These examples reveal how a single invertebrate species can affect multiple levels of the food chain. Their hunting skill has also caught the attention of medical researchers, apparently. Centipede venom has powerful compounds aimed at muscles and nerves, and scientists are now looking into whether some of these molecules could inspire safer, more effective pain medications than the ones we use today. What started like an ecological oddness might, later on, become something that helps medicine, a bit indirectly. Even so, a lot of questions are still out there and not fully answered. Researchers still do not know how often snake predation happens across different habitats, or how climate change and shifting ecosystems will affect these encounters. Future field studies and better tracking tech should make it clearer just how significant these predators really are. At the same time, scientists are checking if snakes could evolve stronger protections against centipedes, maybe via shifts in behavior or through higher venom tolerance. This back and forth shows an evolutionary contest that feels way more tangled than people assumed before. In the end, giant centipedes remind us that nature is packed with surprises. These small but tough predators are reshaping the way we think about ecosystems. They show that even overlooked creatures can steer biodiversity, scientific discovery, and maybe even what medicine might look like later on. From underestimated arthropods to lethal snake hunters, giant centipedes have flipped the predator-prey script in astonishing ways. Their story reminds us that nature is full of surprises, where size is not everything, and survival depends on cunning, venom, and adaptation. If you found this fascinating, be sure to like and subscribe for more incredible discoveries from the natural world. Then, keep exploring by clicking the next video on your screen, where another remarkable creature reveals just how unpredictable and unforgiving the struggle for survival can become.